Alright, this podcast is hopefully she'll explain this test in December of 2018 on the various types of chemical reactions. And so let's get right into it. This first problem here is asking the reaction shown is best described as A. Now you know you have a combustion reaction when you have some hydrocarbon fuel reacting with oxygen to make carbon dioxide and water. You're going to see this reaction quite a bit of times through the test. So this is a B. Now this is called a combustion reaction. Again, you're looking for the two products here, carbon dioxide and water, and oxygen is one of the reactants. Number 2, one of the products of this chemical reaction is, now the products of a chemical reaction are the ones over here on the right side of the arrow. Notice we have water here and we have carbon dioxide. So one of the products is water. Alright, which of the 5 types of chemical reactions is this? So here we have one thing decomposing into two things like that. So this is called the decomposition reaction. The general formula is AB, or some compound, breaking into A plus B. So you can't help but realize that that's what's going on here. Which type of chemical reaction is this? This is really the opposite of number 3. Number 4 is two things combining to form one thing. So it's sort of like this turned around backwards. We call this a combination reaction or a synthesis reaction. It isn't a composition reaction, by the way. The name is combination, so it's actually none of the above. And which of the 5 types of chemical reactions is this? Like we saw earlier, this is a combustion reaction because of oxygen, carbon dioxide, water, and some hydrocarbon fuel. So we call this combustion, which is E. What type of chemical reaction is this? Probably the best way to do this would be to actually write out the picture that's there. We have a nitrogen and 3 hydrogens. So that's the way you could write it. If you wrote the hydrogens first and the nitrogen second, it doesn't matter that much for this test. But we have 2 of these molecules of NH3. So I'm going to go ahead and write the 2 there to show I have 2 NH3s. Here we have N2 gas, just 1 molecule. And here we have 3 molecules of H2. See, there's 3 molecules there of H2. So H2, 3 molecules. So notice here we have one thing breaking down or decomposing into 2 things. So we call this a decomposition reaction. Okay, this next one here, what type of chemical reaction is this? As before, it's best to write it out. So we have magnesium metal and hydrogen chloride. 2 of them are going to react to make magnesium chloride and hydrogen gas. Okay, so notice we have a single here and a couple, and a new single and a new couple. So this is what we call single replacement, which is the D. Same thing here. Let's go ahead and write this out. We have sodium, and here we have copper nitrate. See, this is actually a bracket showing that we're talking about a polyatomic anion. That's a -1 here, and the copper is a +1. And on this side we have copper and we have sodium nitrate. So you can see we have a single and a couple and a new single and a new couple, so this is also called single replacement, D. Alright, now this next reaction, this is a classic combustion reaction. A hydrocarbon fuel reacts with oxygen to form carbon dioxide and water. However, the question is asking about what type of bonding is going on in these molecules. Well, in each case, in all of these, we have covalent bonding, as seen by these little bonds between the atoms like this. They all have those bonds, you see. So this is what we call covalent bonding. There are no ions on here, and it's not metallic bonding. So C. Okay, now write out the balanced chemical equation for this. This threw off a number of students because they just wrote out the picture and forgot to balance it. So this picture is H2, and this is O2, react to form H2O, water. That's fine, and that is the picture you see there, except to balance it, you need 2 of these to 1 of those to 2 of those. So if you didn't balance it, that'd be like 1 point off. A lot of people have the same problem here, where this is metallic bonding. Potassium reacts with chlorine gas to form the ionic compound potassium chloride. This is what you see here. But to balance it, you actually need 2 potassiums and 2 chlorides, 2 potassiums and 2 chlorides. So balancing it again is 1 point. Alright, so here we have, write the balanced chemical reaction for this decomposition. Here we have a molecule of ammonia and another molecule of ammonia. So writing out ammonia, NH3, 3 hydrogens for 1 nitrogen. And I do notice I have 2 of them here. They decompose into nitrogen gas and 3 hydrogen molecules. See, make sure you interpret these as molecules. You've got 3 molecules of H2. That's why there's a 3 here, because you have 3 molecules. And since there's 2 atoms in the formula, that's why there's a 2 here. Alright, now write the chemical equation for this single replacement. So we have magnesium all by itself is single. Hydrogen chloride, excuse me, like that. And that's 1 molecule of hydrogen chloride. I need 2 of them. And then over here we have magnesium chloride. Take care to always put the metal in front, even if the picture doesn't show it. And then hydrogen gas. Okay, so here's metallic bonding, covalent bonding, ionic bonding, and covalent bonding. And there it is. That's the balanced chemical reaction. Okay, now on the last page of the test, you have to balance this chemical reaction. So let's see what we can do here. We have 12 carbons. That means I'm going to put a 12 here, and I have 12 carbons. 22 hydrogens. I have 2 hydrogens, so I'm going to multiply this 2 times 11, which gives me the same as the 22 here. And now we have to reconcile the oxygens. Here I have 1 oxygen, and here I have 2, for a total of 3. Here I have 12 times 2, or 24 oxygens, and 11 oxygens. So okay, on the right here I have 35 oxygens. So that means that over here I need to have 35 oxygens. If I put a 1 here, that means I have 11 oxygens on this side. If I put a 12 here, and that gives me 24 oxygens for a total of 35. So that actually balances it 1, 1, 1, 12, 12, 11. And of course this is a combustion reaction, like we've seen before. Again, I have to balance a few chemical reactions. To do this, we have 3 leads here, so I need to put a 3 here. We have 2 phosphates, so this whole phosphate, PO4, and there's 2 of them, so I'm going to put a 2 here to make 2 phosphates. 6 hydrogens, so I should put a 3 here and a 1. And as you can see, this is a single replacement reaction. I'll just write it SR. Okay, now in this equation we have 2 of these ammonias, so I'm going to put a 2 here to give me 2 nitrogens. That gives me 6 hydrogens here, and 2 is 8 hydrogens. So actually I'm good. I just need to put 1s here and I've got it. This is a combination reaction. 2 things combine to make 1. Okay, now here we have a combustion reaction. We've seen these before. You could start out with putting 5 here to make for 5 carbons, and since I have 10 hydrogens here, you could put a 5 here. But then you'll find out that the oxygens won't work out well, because over here I have 5 times 2 is 10 oxygens plus 5 for a total of 15 oxygens on this side and only 2 here. So nothing I can put here could ever multiply by 2 and become 15. Here's one of those classic cases where you have to double everything that you thought you had. So 5 becomes 10, like that. That's a 10 there. That also doubles this, so now I have 30 oxygens on this side. So meaning I need 15 here. So the answer is 2, 15, 10, 10, and this is combustion. This has all of the signs of combustion. As you can see, a hydrocarbon fuel, and oxygen on one side of the arrow, carbon dioxide and water. Okay, so now we have this chemical reaction. I have 3 lithiums here and 1 there. I'm going to put a 3 here to fix the lithiums. Here I have 3 ammonias. The little 3 means I have 3 like in the parentheses. So I'm going to put a 3 here to reconcile that. 1 nitrogen there and 1 there, so I think it will work if I just put 1s there. That's right. And this is a double replacement. I have 2 couples becoming 2 new couples. So this is double replacement. Or it's also called double displacement. But I'll just call it double replacement. And here we have this equation is actually already balanced with no coefficient higher than 1. That sometimes does happen. And one thing is decomposing into 2 things, so this is called a decomposition reaction. Finally, you have a few of these problems we've seen before where you're counting the number of atoms in the formula. Always start with the parentheses. Inside that parentheses there are 4 atoms. This means that that's times 2 for a total of 8 atoms there, plus this 1 on the outside, lead. There's 9 atoms in this formula. Just to show you what this looks like in a more drawn out view, I'll put it over here. This is 2 aluminum atoms and 3 sulfates, SO4. See that? 3 sulfates. So this is 5, and this is 5, and this is 5. That's a total of 15 atoms, plus 2 is 17 atoms. Now here we simply have to add up those atoms. So 22 and 12 gives me 34, plus 11 is 45 atoms. Here, drawing this out, I have 1 magnesium and I have 2 hydroxides. So just look at what I'm showing you. That parentheses 2 means there are 2 hydroxides, and then this 2 out front here, that is a really important thing because that actually multiplies everything here by 2. So here I have 1, 2, 3, 4, 5 times 2 for a total of 10 atoms in that formula. This is an easy one. I have 4, 5, 6 atoms. 6 atoms in that formula times 2 is 12. Inside the parentheses here I have 5 times 2, that little 2. Okay, so that's 10. And outside I have another additional 5 for a total of 15. Okay, that wraps up the test. Hopefully you're able to see this during the break and be prepared to come back for a retake if you didn't do too well.